Welcome back, class 9th. We were doing exercise 13.2. We have done 9 questions out of the 11 questions given in the exercise. Today we are going to do the remaining 2 questions. We are left with question number 3 and question number 9. Let's begin question number 3. Let's take a look at the statement first. So question number 3 is a metal pipe is 77 centimeters long. So they have given you a picture also. The inner diameter of a cross section is 4 centimeters and the outer diameter being 4.4 centimeters. You've been asked to find out 3 things: the inner curved surface area, the outer curved surface area, and the total surface area. So before we begin with this, let's understand how the pipe will actually look like and what would be its cross section, because the measurements are given for the cross section. Let's draw a rough picture in the notebooks. So we are doing question number 3. So the metal pipe would be cylindrical in shape as they have described in the question, and they have given you a picture also. Since the pipe is hollow, that means you will be able to see a cylindrical shape inside as well, and the thickness will be uniform. Now this is the metal pipe. Its length is given as 77 centimeters. Now what they have given is, they have given the measurements for the cross section. You studied about the concept of cross section in 7th standard when you were introduced to solid shapes. So let's just revise what a cross section is. Whenever we obtain the cross section for a solid object, the easiest way to understand this is try thinking about slicing the solid object very thinly. So imagine that this pipe is sliced very thinly. What will be the shape of those slices? For this, you could imagine a cucumber maybe. So the cucumber resembles a cylinder, although it's not exactly a cylindrical shape, but it does resemble a cylinder. So if the cucumber is sliced very thinly, what will be the shape of those slices? The shape of those slices will be circles. That is what the cross section is. For any solid shape, the cross section is a 2D shape. So in case of a metal pipe, the cross section would be a circular shape which is hollow from the inside. So there would be metal here. This kind of resembles a disc or a CD. So it's hollow from the inside. There is a small circle and there is a larger circle. That's why what they have given is, if this represents the center for the pipe or for the cross section, then they have given the outer diameter and they have given the inner diameter. So let us say the outer diameter is represented by capital D. This is given as 4.4 centimeters, and the inner diameter, let's represent the inner diameter by lowercase d. This is given as 4 centimeters. So before you start with this question, you should be able to understand this, what a cross section is and how the measurements have been given. Now the first part is, you have to find out the inner curved surface area. So for the inner curved surface, means for this inner cylinder, you have to find out the curved surface area. So we will be using the inner dimensions and we will apply the formula for the curved surface area. The formula for the curved surface area is 2 pi RH. Now the only difference will be, while we evaluate or calculate the inner curved surface area, the length of the pipe remains same. So the height will be same whether we are taking this outer cylinder or we are taking the inner cylinder. Only the radius changes. So for inner curved surface area, I am using inner radius. H being 77. If you want, you can write down for yourself the height of the metal pipe, which actually will be the length. So this will be 77 centimeters. The curved surface area uses radius. For inner curved surface area, I'll be using inner radius. Since I have represented the inner diameter by lowercase d, I am representing the inner radius by lowercase r. Let's find out the r from here. Small r, diameter divided by 2, this will be 2 centimeters. And same way for the second part, I will be requiring the radius of the outer circle. So for the radius of the outer circle, I'll be using the diameter of the outer circle. So I'm using capital R for the bigger circle. The diameter 4.4 divided by 2 is 2.2 centimeters. Now for inner curved surface area, this is the formula. The only difference will be we have to use inner radius. Be very careful using the values given to us. The radius is 2 and the height is 77. So this gets cancelled. I'm left with these values. Multiplying, the answer comes out to be 968 centimeter square. Now let's calculate the outer curved surface area. For the outer curved surface area, now the formula is same, 2 pi r h, but instead of small r, now I'll be using capital R. So you can notice for the outer I'm using capital R, for the inner I use the small r. The formula is same. Let's evaluate. Using capital R, it is 2.2. The height is 77. Convert the decimal into a fraction and then solve. This becomes 22 by 10 into 77. This gets cancelled. So I'm left with 2 into 22 into 22 into 11 over 10. So again, although you might be tempted to cancel 2 and 10, I'm not cancelling it. I'll use this 10 to introduce the decimal back in the product of the numerators. And the product of the numerators comes out to be 10,648 over 10. So this is 1064.8 centimeter square. So we have obtained the curved surface area for the inner cylinder and the outer cylinder. The third part, which is the most important part, you have to find out the total surface area. Now to find out the total surface area for this pipe, we shall not be using the formula that we usually apply to find out the total surface area of a cylinder, because usually our cylinder is made up of just one cylindrical shape. There is not a second cylinder present inside. So for this, there will be the curved surface and the top circle and the bottom circle. But this is not the case here. So this formula, the formula 2 pi r h, the curved surface area, plus the area of top and the base circles, this will not be applicable here. In this case, when we have to find out the total surface area, we need the outer curved surface area, the outer cylinder, then we need the inner curved surface area, and the third thing that we require is the area of this ring. So you can see there is a disc shape, like this kind of circle will be present on top, and another circle of the same shape will be present at the bottom. So we need to find this area as well, the one I have shaded, and this actually is the area of a ring. So the closest object that I could find to explain this was this sellotape. So you can see now I've got this sellotape. This is cylindrical object. There is a cylinder outside and there is this cylinder inside. So when I want to find out the total surface area for this, I'll be calculating the area of the outer surface This is the curved surface area of the outer cylinder. Then I want to find out this inner curved surface area. And then third thing I want to find out is this little surface, which is made up of a ring, a bigger circle, and there is a smaller circle. So the area that lies between the boundaries of these two circles, this surface on the top that you can see. This is what I need to find out. This will be on the top as well as on the bottom. So the curved surface, so the total surface area will be given by inner curved surface area plus the outer curved surface area plus the area of two rings which are present on top and base. We already have calculated inner curved surface area in the first part, outer curved surface area in the second part. We need to first of all find this. So before we come back to this, let us find out the area of the two rings. Now, area of rings. Ring is actually formed by having two concentric circles. So let us say we have two concentric circles. This one is with radius r. The smaller circle has radius represented by small r. The outer circle has radius represented by capital R. So if we want to find out the area of this shaded portion, so area shaded is actually the area of ring. This is also called as the area between the boundaries or the circumferences of two concentric circles. So this is the boundary of the smaller circle, this is the boundary of the bigger circle, and between these two boundaries, the area which is present is known as or is referred to as the area of a ring. And how do we calculate this? This is given by area of the outer circle or the bigger circle minus area of inner circle, that is your smaller circle. So if you want, you can write this as a note for yourself, although you have done this in 7th standard. If you do not remember this, just for your help or guiding you when you revise this chapter again, note it down on a side. The area of the outer circle. Now area of a circle is given by pi r square. So the area of outer circle will be pi r square. Now I'm going to use the r for the outer circle. So r square, pi r square minus pi for the smaller circle, I'll be using small r. And pi is common. So this will be pi common. In the brackets I have capital R square minus small r square. And since in this particular cylindrical pipe we have two rings formed, so I'll be multiplying this area with 2. So let's find out the area of two rings. This will be given by 2 because there are two rings multiplied by this. Pi in the brackets we have r square minus r square. Let's evaluate by using the values. Pi is 22 by 7. In the brackets, the capital R from here is 2.2. The small r is 2. Solving. I am applying the identity here. You can evaluate the squares. Square for 2.2 minus the square for 2. I'm going to apply my identity, a square minus b square. So what I'll have a plus b into a minus b. This actually simplifies my work. I don't have to go calculating these squares. So this will be 4.2 into 0.2. Let's convert the decimals into fractions and evaluate. This gets cancelled. So 44 into 6 into 2 over 100. So evaluating this, the product comes out to be 528. In the denominator I've got 100. So this will be 5.28 centimeter square. Now let's find out the total surface area of the pipe. So from here, from what I have written here, I need to add these three: the inner curved surface area, the outer curved surface area, and the area of two rings that I just obtained. So answer number 1 plus answer number 2 plus this answer, the answer just obtained. So I've got 968 from the first part, 1064.8 from the second part, and I just calculated 5.28. Adding these, you will get your answer as 2038.08 centimeter square. So this is the total surface area for a pipe, and this is very important question. The next question that we are going to do is question number 9th. Let's take a look at the statement. Question number 9th. The question consists of two parts. The first part is find the lateral or the curved surface area of a closed cylindrical petrol storage tank that is 4.2 meters in diameter and 4.5 meters high. So this is a very simple question. The first part is direct question. You have to find out the lateral or the curved surface area for the cylindrical tank. The formula will be 2 pi r h. We need r and we need h, for which we've been given the diameter and height is directly given. So find r, h is given, apply the formula, and we will have the lateral or the curved surface area using 2 pi r h. Then second part, how much steel was actually used if 1 by 12 of the steel actually used was wasted in making the tank. Let's solve the first part and then we shall come to question numbers, this question's second part. So for the first part, the diameter is given. The diameter is 4.2 meters and the height is 4.5 meters. Since we need the radius, let's find out the diameter divided by 2. This will be 2.1 meters. Height is here. So for the curved surface area, the formula is 2 pi r h. So this is a simple application of the formula. We already have done so many questions like these using the values. So for solving, I'll be changing these decimal numbers into fractions. So this will be 21 by 10 into 45 by 10. So this gets cancelled. Now I'll be cancelling these. Now why I have cancelled this 10? Because I am 100% sure that this 5 is also going to be cancelled. That's why. Otherwise I wouldn't have bothered this 10. I would have left it as such. So 5 9s are 45. I'm left with 22 into 27 by 10. So this comes out to be 594 over 10, which is 59.4 meter square. So this is the curved surface area of the tank they're talking about. Now for the second part, now what they're exactly saying is that the sheet which was used to make the tank, there was some wastage. Now this could actually be thought of as a practical example. Suppose a person gives a piece of cloth to the tailor for making a shirt or maybe making a trouser. The piece of cloth that the person buys from the market would actually be rectangular in shape. So he gives that rectangular piece of cloth to the tailor. The tailor makes the trouser or the shirt by cutting that piece of cloth into the required shape and then stitching it up. And while he does so, there is some wastage. Similar thing happened here. While making the storage tank they're talking about in this question, the sheet that was actually bought must be of a shape, either a rectangle or maybe a square. We are not concerned about the shape, we are only concerned about the area of that sheet, because that is what makes up the tank. So assuming that the area of the sheet, whatever shape it was, irrespective of that, so whatever the shape of the sheet is, irrespective of that, we will assume that the area for that sheet which was actually bought in the beginning is X. and let the units be same because we're working in meter square. So let us say the area of sheet actually used. So this is before it was cut into shape required or welded together to form that tank. So let's assume that the area is x meter square. So for the, if you want, you can imagine that the sheet is rectangular in shape and the area for this sheet is x meter square. Irrespective of its length and breadth, we are not concerned with that. Now what happened when the sheet was used to make the tank? There must be some cutting and welding and wastage. So for that they have given the wastage. The wastage of sheet happened. So how much wastage happened? It is 1/12 of the area of the sheet. So wastage of sheet while making the tank, this is given as 1/12 of x. So this will be 1/12 into x, which is x/12 meter square. Again, the wastage will be in terms of the area of the sheet that is wasted. Then this means the area of sheet which makes up the tank. So the metal sheet that you actually see in the tank is given by the material bought minus the wasted material. So this is the material which was actually bought, this is the wastage, and from here we can find out how much material was actually used to make the tank. Or I would say the material that is actually visible in the tank. So we can only see the material which is used, we cannot see the wastage. So this is the area of the sheet which is visible to us, and this is exclusive of the wastage. Now according to us, now this is what is given in the question. Some sheet was bought, there was some wastage, and out of this, if we take away the wastage, this is the material left, and this is what was used to make the tank, which we can see in the tank itself. But according to us, according to our knowledge, we know the area of sheet which makes up the closed tank. Now if there was a separate question where you had to find out the area of sheet needed to make a closed cylindrical tank, what would you find out? Yes, you would find out the total surface area of the tank. Now this is something which we are aware of. This is how we do our question. So what should happen here? This value, which has been calculated in terms of the sheet actually used, and the total surface area of tank, these should be equal. So our equation will be, therefore 11x/12 is equal to the total surface area of tank. Now let us evaluate for the total surface area of tank. The formula will be 2 pi r into h plus r. Let's solve this and then we will solve this equation. This will be 2 into 22/7. The radius is 2.1. In the brackets, the height is 4.5 plus the radius is 2.1. So 2 into 22/7. This is 21/10. This comes out to be 6.6. which can be written as 66/10. Simplifying, these get cancelled. So I'm left with 44 into 3 into 66/100. So this on simplification comes out to be 8712/100, which is 87.12 meter square. So this is what we shall be using here. So 11x/12, this is not your rough work, this is just the calculation of the total surface area, and we will be using this value here. So I'm using it as a fraction. X comes out to be 8712 over 100 into 12 over 11. So apply your divisibility rules. This number is divisible by 11. Divide it. So X comes out to be 792 into 12 over 100. This is 9504 over 100, and hence this is your answer. So the area of the sheet which was bought was 95.04 meter square. There was some wastage, and after that wastage, the material which is actually visible, that looks or appears to be used in the tank, is this. So you can see this is the actual material bought and this is the one which was used. So there was some wastage and we are not aware of that. Usually we just find the total surface area and we tell how much material is used to make the tank.